Let's go through Lico 2598, smallest missing non-negative integer after operations. It gives us integer nums and also integer value. And for every number in these nums, you can add or delete the value as many times as you want. And we want to looking for the MEX after we do add those operations. So what is MEX minimal exclusive is that the array that the smallest missing non-negative integer in it, for example, minus 1, 2, 3. So the we are missing 0 and this one missing 2, right? So we as we know we can use this value to manipulate on this num as many as we times we can, right? So that means every number, what its initial value, you will not, it doesn't matter, right? It doesn't matter what the initial value it is. For example, if we have value to um, be 7, and so initial value, for example, 1 will be as the same as the initial value of 8, right? And the same as the initial value of 15. So if if we have 1, 8, 15, that means, for example, we have this one is 22, right? So that means for this number which is mod has remainder to be 1, we can form up to 15, right? So, so for example, this is 701, right? That's the same as 8. So that means we are still able to form to 15. But for this number to be 22nd, we are not able to form it, right? Because we want to have the minimal exclusive. So what we want is that we have the remainder and multiple by this have this value multiply by 0 plus remainder and multiply by 1 plus remainder. So that means we are not able to, so the for this remainder, we're not able to, cannot. So this is not 22, right? So if we have, for example, we have 9702 or, or minus 5, right? So all of this number, they are remainder divided by 7, that will be 2, right? And for example, we have um, 9 multiple times. So we can consider all of this to be 2. And what when we form it, we have from 2, 9, 16, 23, right? So what we can form cannot form is 30. So well, see, this is the counts. If these are, so we just count this one as 4, right? So what we cannot form is this kind of value is 7 multiplied by 4 plus the remainder, right? So this is for the number which mod equals to 2, we cannot form it. So for every, so what we do is that for those number, if we have mod 0 to mod 1 and mod 2, and until mod value minus 1, right? We're trying to find what is the number, smallest number we cannot form. And that will be our first minimal exclusive. So let's write code for this. So as we know, what we do is that we just compose user count, right? Count equals new int should be valid, right? So what we do is um, for int I equals 0, I smaller than Actually, we don't need this one. We just need for every num in nums. So we're going to have count num mod by value. Should increase. But this one, mod by value, it may have a negative number, right? So for Java, this will be negative. But for Python, negative should be fine, right? So for Java, what we do is that we should add a value and the mod value again. And then what we do is, first we have int result equals integer dot max value. What we do is that for int um, I equals 0, I is smaller than value I plus plus. So the result equals max dot mean result in the count I multiple by value plus I, right? And in the end, return result. It will be if there are n number, this is O(n), right? This is the O value. So it will be O(n) plus value time complexity, and the space will be O value. Convert this to Python. Um, so count equals this one, multiplied by value. And for num in nums, let's see, count num mod value plus equal to 1, right? So in this case, it is negative. It should still be fine, right? And then what it is result equals float IF, and for I in range value, result equals mean result value multiplied by count I plus I. In the end, return result.